Hi, the subject we have before us now is chemistry, and under this chemistry, we want to take one of the topics under gas laws, which is Graham's law of diffusion. So, what does that Graham's law of diffusion say? Graham's law of diffusion states that under constant temperature and pressure, the rate of diffusion of any gas is inversely proportional to the square root of its density. That is, the rate of diffusion of any gas is inversely proportional to the square root of its density under constant temperature and pressure. So from this expression, this is a mathematical expression, we can generate further formula from it so that we'll be able to see the practical application mathematically of this topic. So if we remove this constant of proportionality, we have k over square root of density, and when we cross multiply, we have that the rate of diffusion is multiplied by the square root of the density equals a constant. Then from here we can say that r1 square root of density 1 equals r2 square root of density 2 up to rn square root of density n. Then from here we can generally deduce that r1 over r2 equals square root of density 2 over density 1. What is the essence of this expression that we have given? We can measure the rate of diffusion of gas A, for instance, with respect to gas B, knowing fully well that we know the density of gas A and B. We also note that the rate of diffusion of gas is volume of the gas diffused divided by the time it will take that gas to diffuse. So we can rewrite this equation in terms of volume and time by saying R1 will now be V1 over T1 divided by R2 will now be V2 over T2 equals to the density of the second gas over the density of the first gas. Then mathematically, if we remove this division sign, we have V1 over T1 times T2 over V2 equals square root of density 2 over density 1. Then we have a condition that the gas will have the same volume. So if the volume of first gas is equal to the volume of the second gas, then we can say that T2 over T1 equals square root of density 2 over density 1. Then there are some time when we have the gas diffusing at the same time. So we can say if T1 equals T2, then from this expression we have it as V1 over V2 equals square root of density 2 over density of gas, the first gas. We also note that there is a relationship between density and relative molecular mass. The relative molecular mass of a substance is directly proportional to the density. So we can rewrite, if I label this as equation 1 and this as equation 2 and this as equation 3, because density is proportional to RMM, relative molecular mass, equation 1 can translate to R1 over R2 equals the relative molecular mass 2 over relative molecular mass 1. Let's call that one equation 4. Then also equation 2 can translate to T2 over T1 equals relative molecular mass 2 over relative molecular mass 1. Let's call that one equation 5. Then equation 3 can translate to V1 over V2 equals relative molecular mass 2 over relative molecular mass 1. Let's call that one equation 6. With these 6 equations, we should be able to solve any mathematical related problem on Graham's law of diffusion. So for us to test our knowledge of this topic, I have 3 questions I will really want us to look at. The first question states that if 30 cm cube of oxygen, the first gas we are considering is oxygen, the volume of that gas is 30 cm cube, diffuses through a porous pot in 7 seconds. The time taken for oxygen to diffuse is 7 seconds. How long will it take 60 cm cube of chlorine, another gas we are considering is chlorine, and the volume is 60 cm cube? We want to check the time it will take chlorine to diffuse through the same pot. If the vapor densities of, that is, the density of oxygen is 16 and the density of chlorine is 36. So we have the volume of oxygen to be 30 cm cube, and the time it will take that 30 cm cube of oxygen to diffuse is 7 seconds. We are measuring the rate of diffusion with respect to chlorine, whose volume is 60 cm cube. We want to know the time it will take chlorine to diffuse. So we can pick any of the formulae we have listed before now to solve the problem we want to solve. So we have that if our first gas is taken as oxygen, so VO2 divided by time it will take oxygen to diffuse times the time it will take chlorine to diffuse over the volume of chlorine that has diffused, equal to the density of chlorine divided by the density of oxygen. You know, when we are trying to prove the formula, we used 1 and 2. So 1 means the first gas we choose to consider, and 2 the second gas we choose to consider. So what's the volume of oxygen given? 30 divided by the time taken for that volume to diffuse is 7 times the time taken for chlorine to diffuse over volume of chlorine that's diffused. Then the density of chlorine is 36, that of oxygen is 16. So from what we have here, 30 here 1, 30 here 2, we have TCl2, 7 times 2 is 14, equals to 4 can go in 36, 9, 4 in 16, 4. We know that 9 and 4 are perfect square. So what is the square root of 9? 3. The square root of 4? 2. So if we cross multiply, TCl2 times 2 equals 14 times 3. Divide both sides by 2 because we are looking for the time it will take oxygen to diffuse. 14 times 3 divided by 2. So time taken for chlorine to diffuse is 21 seconds. So if it takes 7 seconds for 30 cm cube of oxygen to diffuse through a porous plug, according to our solution, it will take 21 seconds for 60 cm cube of chlorine to diffuse. I hope we get it the way we have solved it. I said we are going to take 3 examples. The second one reads thus: a given volume of methane. We all know the formula of methane, that's CH4. A given volume of methane diffuses in 20 seconds. How long will it take the same volume? They have given us one clue to solving it, that is the volume of methane is equal to how long will it take the same volume of sulfur 4 oxide, VSO2, meaning that the volumes are the same. Then of course, if the volumes are the same, we know what the time will be. How long will it take the same volume of SO2 to diffuse under the same condition? So the time taken for methane to diffuse is, according to the question, is 20 seconds. In this case, we're not given the density of methane and SO2, but we can calculate it. We can express this Graham's law of diffusion in terms of relative molecular mass too. So we need to know the relative molecular mass of methane. As you know, the atomic mass of carbon is 12 plus hydrogen is 1. So we have 4 atoms of hydrogen here. So we say 1 times 4. So that will be 12 plus 4, which is what? 16. Then we need to calculate the relative molecular mass of sulfur 4 oxide 2. The atomic mass of sulfur, as we know, is 32. And we have 2 atoms of oxygen here, of which one of it is 16. So say 16 times 2. So that is 32 plus 32. So the relative molecular mass of SO2 is 64. So the formula of which 6 formulae we wrote the other time, the one we are going to make use of is the time taken for SO2 to diffuse over, because our SO2 is taken, I want to take it as the second gas. So T2 over the time taken for the first gas, which is methane, to diffuse, is equal to the relative molecular mass of SO2 divided by the relative molecular mass of methane, because the volume is the same. So the time taken for SO2 to diffuse were not given. That's what we are looking for. So TSO2 divided by the time taken for methane to diffuse, which is 20, equals to the relative molecular mass of methane of SO2 is 64 and that of methane is 16. So we have that TSO2 over 20 equals 16 divided by 64 divided by 16 is 4, square root of 4. So TSO2 over 20, what's the square root of 4? 2. So if we cross multiply, the time taken for sulfur 4 oxide to diffuse under the same condition is 20 times 2. So which is 40 seconds. So it will take 40 seconds for sulfur 4 oxide to diffuse, while it will take methane 20 seconds to diffuse. Like I said, I want us to look at 3 questions in all. The third one reads, a gas X diffused through porous partition at the rate of 3 cm³ per second. The rate of diffusion of gas X, we can represent that one as Rx, is 3 cm³ per second. A gas X diffused through a porous partition at the rate of 3 cm³ per second. Under the same condition, hydrogen diffused at the rate of 15 cm³ per second. The second gas we are considering is hydrogen gas. That one diffused at the rate of 15 cm³ per second. So the real question there is, what is the relative molecular mass of X? So we know the relative molecular mass of hydrogen to be, hydrogen atomic mass is 1 and we have 2 atoms of it, so 1 times 2, that's 2. But we don't know the relative molecular mass of gas X. That's what we are looking for. So we have it in one of those formulae we outlined the other time. If we take X as our first gas, we can say rate of diffusion of X with respect to that of hydrogen will be equal to relative molecular mass of hydrogen divided by the relative molecular mass of X. So the rate of diffusion of X is 3 and that of hydrogen is 15, equals to the relative molecular mass of hydrogen is 2 divided by the relative molecular mass of X. Three can go in 15 5 times. So we have 1 over 5 equals square root of 2 over relative molecular mass of X. So if we square both sides, squaring both sides, we have 1 over 5 all squared. And why are we squaring both sides? So that we can remove this square root sign. 2 divided by Rmn of X. So if we square this, we have 1 over 25 equals 2 over Rmn of X. Cross multiplying, Rmn of X equals 25 times 2. So the relative molecular mass of X is 50. I hope with these 3 examples, we've been able to, we can on our own apply Graham's law of diffusion to any question related to the topic. Thank you very much.